we have two trig terms, sine of x plus pi over 4 and sine of x minus pi over 4. So I really can't combine them because they're two different terms, so I cannot isolate the one single trig. So instead I'm going to have to use the sum and difference formulas, to evaluate like we did over here. This one's alpha, this is beta, there's plus sign between, and I'm going to do the same thing over here. So let's do this example first. Sine of x plus pi over 4. So if I go to my formula, sine of alpha plus beta is going to be sine cosine plus cosine sine. Okay, so let's rewrite that. This is going to become sine cosine plus cosine sine. Let me just make sure that's what the formula said. Sine cosine, cosine sine, and just make sure that you replace alpha and beta appropriately. Now let's do the same thing over here. This plus sign is from the formula. And sine of alpha minus beta, sine of alpha minus beta, this time I'm using the sign on the bottom, is going to be sine, it's the same thing, but with a minus sign in between instead of a plus sign. So let's go back and here write sine of x cosine pi over 4 minus cosine of x, not plus, cosine of x times sine of pi over 4. All I'm doing is following the formulas. Now, what do you notice here? Are there like terms? Yes, so be careful with the like terms. This one matches this one right here, and this one matches this one right here. And what do you notice about that one? Yeah, this last one right here, cosine of x sine of pi over 4, is going to cancel out with this minus 1. So I'm just going to eliminate these two right here. And I'm going to be left with 2 sine of x cosine of pi over 4 is equivalent to 1. Now I notice there's a pi over 4. What is pi over 4? 45 degrees. Good, 45 degrees. So let's go ahead and sketch 45 degrees. So 45 is going to be, let's do our right triangle. 1, 1, square root of 2. Cosine of 45 degrees is adjacent over hypotenuse. Adjacent over hypotenuse, which is 1 over square root of 2. So let's replace that right there. This right here, cosine of pi over 4, I'm going to replace it with 1 over square root of 2. So it's going to be 2 sine of x times 1 over square root of 2 is equivalent to 1. Now be careful here in the algebra steps. I'm going to multiply 2 and the square root of 2, so I have 2 times 1 over the square root of 2, so I have 2 over the square root of 2 times sine of x is equivalent to 1. Now, in some cases, you may want to simplify before you divide, or in this case, multiply by its reciprocal, or you can do that at the very end. If, for example, you don't simplify right now, I'm going to go ahead and multiply by the reciprocal, because I want to cancel out this term right here. So that's why I'm doing times the square root of 2 over 2, the reciprocal there of 2 over square root of 2. That way, these cancel out, and I'll be left with sine of x is equivalent to the square root of 2 over 2. Now, if we recall, I gave you an example last time where we ended up with this. If I use those numbers, it may not be the special right triangle that we're used to seeing. So what you may want to do here is just rewrite this where you, in a sense, it's simply called rationalizing the numerator, but we can kind of think about it as, since we kind of know it as simplifying radicals, I'm going to go ahead and kind of unsimplify this. So go back and multiply by the square root of 2 over the square root of 2. That way you end up with, on top it's going to be 2 over square root of 2, which is 1 over square root of 2. Which I know is this what we had gotten by coincidence, but it was because I didn't simplify it from the very beginning. But I'm going to, instead of using this square root of 2 over 2, I'm going to go back and write it like this. Sine of x is equal to 1 over the square root of 2. Alright, and these are the problems that we did last time. If I have sine of x, this is my angle. I don't know where this is, so I'm going to sketch the possible x locations. So x could be here, x could be here, quadrant 3 or quadrant 4. Let's write or sketch or write triangles associated with each one of these. X could be here, the reference angle on these other ones, and label opposite 1 hypotenuse square root of 2. So opposite 1 hypotenuse square root of 2 on every right triangle that I see. I go back and based on the location, this one has to be negative and this has to be negative because of its downward location, which means that I eliminate these because on these, sine, if you want to put a note, sine of theta or x is equal to negative 1 over square root of 2, not positive like the problem states. What's the reference angle, or what is x equal to? 45. Now the last thing, of course, is what we've been doing. From the positive x-axis, this terminal side is the 45 degrees. Simple there. So x equals 45 degrees. But when I go to this one from the positive x-axis and this terminal side, how many degrees is this angle over here? 135. So x over here is 135. So just be careful that x down here is a reference angle, but we want the actual angle. And the last thing would be to actually write out our answers. I'm going to change these back to radian, which is pi over 4 for this one. And this one is, yes, 3 times 45 gives me 135, so 3 pi over 4. So I would say x equals to pi over 4 plus 2 pi n, or x equals to 3 pi over 4 plus 2 pi n. And don't forget, you kind of have to mention in here, n is any integer. On your handout, you're going to see that they do write this, or sometimes, well, actually, I gave you all a free response, but sometimes they may write it in set notation, where they put the squiggly brackets. So just be careful with how you write your answers. All right, so just be careful there. We started off with, this formula up here. I'll scroll down. I know some of you are still copying it. But we start off with sine of x plus pi over 4 plus sine of x minus pi over 4. We kind of had to use the sum difference formulas. We simplified it a bit using algebra and our regular trig. And then we went back to these right here, where we had to solve sine of x is equal to something, so we had to do our sketch. So make sure that if you're still not familiar with these equations, like we did in 5.3, you do have to practice those right there, especially without a calculator. All right, any questions?